Hi guys, welcome to Lesson 4.6, Formalizing Relations and Functions. Our objective for today is that I can determine whether a relation is a function, and I can find the domain and range and use function notation. So, new vocabulary terms, the domain is going to be our inputs, and those are our x values. The range is our outputs, and those are going to be our y values. The vertical line test, we touched on this on an early lesson, but we're coming back to it now. If any vertical line passes through more than one point of the graph, then the relation is not a function. And function notation is writing an equation involving x and y with f of x replacing y. The function of x is replacing y. All right, so let's dive right into this. Our essential understanding is a function is a special type of relation in which each value in the domain is paired with exactly one value in the range. All right, problem number one, identifying functions using mapping diagrams. So the list of what you have there, or we have a list of ordered pairs, and then we have the domain and the range. And this setup is called a mapping diagram, and you'll see why in a moment. We want to identify the domain and range of each relation and represent each with the mapping diagram and identify, is it a function? So the first thing I'm going to do is I'm going to list all of my entries into my domain, which, if you'll remember from the vocabulary, is my inputs, the x values. So I have 4, 5, and 7. And I'm going to list all of my y values. I have a 0, a 1, a 2, and a 4. So, first thing we do is we are going to connect the lines from our x coordinate to our y. So we have a point at 4, 1, so we draw a line there. We have 5, 2, draw a line there. We have 7, 4, draw a line there, and we have 4, 0. So each input, according to our definition of a function, has to lead to exactly one output. Does 4 lead to exactly one output? No, because it could be either 0 or 1. So this is not a function. Letter B. We're going to start by writing our entries in. So we've got a -2, a -1, a 4, and a 7. Our y values, we have a -7, a -4, a 2, and a 1. So now I need to make my connections. So -1, 1 is going to go there to there. -2, 2 is going to go from there to there. 4, -4 goes from there to there, and 7, -7 goes from there to there. Now, does each of our inputs have exactly one line coming away from them? They do. So this would be a function. Okay. Letter C, we have -3, 3, 4, and 6. Our range, they all go to 3. So now we draw our diagram. Well, -3 goes to 3, 3 goes to 3, 4 goes to 3, and 6 goes to 3. Is this a function? Yes, it is. And the reason for that is that all of these, each one of these has a distinct value that it goes to. -3 only goes to +3. You could have multiple inputs go to the same output. That's okay. That is a function. That is a horizontal line. Something that's just y equals 5, or in this case it would be y equals 3. No matter what we put in for x, we always get 3 as our output. All right, let's take a look at another special case with letter D here. So our domain, our inputs we see all of them are 3, and our outputs are 4, 6, 7, and 9. So in this case, 3 goes to 4, it goes to 6, it goes to 7, and it goes to 9. So this one input has 4 different outputs. So that is not a function. And an example like this would be a vertical line, where something of the to the effect of x equals in this case it'll be x equals 3. Our input will always be 3, no matter, and our output will vary infinitely. So I want you guys to try letters A and B on your own. All right, so in order to go over these, we need to first list out our domain, our values in our domain and range. So in the domain, we have 3, 5, 6, and 9. In our range, we have 2, 3, and 5. So 5 goes to 3, 3 goes to 5, 6 goes to 3, and 9 goes to 2. Is this a function? Yes, it is. Each of our inputs has only one line coming away from them, so this is a function. Okay, letter B. List our points in our domain. We have 1, 3, and 5. Range is 4, 8, and 10. So now we connect our points. 3 goes to 4. 5 goes to 8. 1 goes to 10. And 3 also goes to 8. So is this a function? No, it is not. Because 3 has 2 separate outputs. It can be a 4 or it can be an 8. All right. So for problem number 2, we're going to address the vertical line test. And if we remember from our definitions, the vertical line test is we put a vertical line on our graph, and if it touches more than one point, it is not a function. So I'm going to use the edge of this pad of Post-it notes as my vertical line. And as you can see, when I push this line across the graph, it is only going to touch one point on that graph at any one given point in time. So this is a function. And this would be an example of a squared graph. So this is a parabola. That's the shape we call it. These are quadratic equations, which we'll deal with in second semester. All right. How about the circle? Letter B. If I move my vertical line across it, I see I'm touching here and here. So that x value is going to have 2 potential y values, so that is not a function. All right, how about letter C? We have a curve. This is a cubed graph. So as I go across, it looks like I'm only touching at one point at any spot on that graph. So this is a function. Letter D, we have, not even sure what would create this, but it would be something absolute value related. So if I put my vertical line across it, you can see that here and here I'm touching 2 different points. So if we were to actually just draw in a vertical line on our graph, you would see that that vertical line touches a point there and it touches a point there. So this is not a function. Okay. All right, I want you guys to try letters A, B, C, and D, and then we'll go over them. All right, so if we take a look at letter A with our handy-dandy straight vertical line, if I put a vertical line on there, I am hitting 2 points on that graph, so that is not a function. This is called a hyperbola. You'll probably see that in Algebra 2 or pre-calc. All right, how about this one? We have a vertical line. So if I put a vertical line on that and I apply the vertical line test, well, it looks like I just kind of drew over that line. So this is not a function, because there are infinitely many points that would be on that vertical line. All right, next up we have letter C, which is a sine graph. So this is one of our trigonometry functions. And if I just put a random line on here, and we can see it's a pattern that's repeated over and over across the entire grid, there is only one place that that line is crossing our graph, so that is a function. And letter D, this is going to be a graph of x to the 4th power, so it's more of a broader U shape than the parabola, so that is a function. Because there is no point on there. If you look at a vertical line, we are only going to be crossing at 1 point. All right. Problem number 3, evaluating a function. So the function w is equal to 350x represents the number of words that you can read in x minutes. How many words can you read in 6 minutes? So the way we write this in function notation, so w of x replaced our y. So we have w of 6 is equal to 250 times 6. The function of 6 minutes, so 6 minutes, is equal to 250 words per minute times 6 minutes. So w of 6 is equal to 1,500. This is a word problem, so we need to have units. 1,500 words. All right. Letter B, the National Assessment for Educational Progress, the NAEP test. Tests select 8th graders. The average math test score can be represented as a function of the science scores by f of s is equal to 0.8s plus 72, where f of s is the math score and s is the science score. What is the math score that corresponds with a science score of 308? So we have f of 308, because that's what we're going to substitute in for s in our equation, is equal to 0.8 times 308 plus 72. F of 308 is equal to 318. And 0.4. And we're not really given any units on this one, so there's nothing that I would put in there for units. We're just told it's some kind of score. All right, so I want you guys to try letters A and B. So letter A, the function t of x is equal to 65x represents the number of words that you can type in x minutes. How many words can you type in 7 minutes? So we have t of 7 is equal to 65 times 7. So t of 7 is equal to 455 words. So in 7 minutes, you would be able to type 455 words. The temperature of the atmosphere decreases by about 5 degrees Fahrenheit for every 1,000 foot increase in altitude. The function f of h equals 43 minus 0.005h can be used to find the temperature, F of h, based on being h feet above the ground on a 43-degree Fahrenheit day, which was supposed to be the high today. What is the temperature at 3,500 feet above the ground? So I want to know F of 3,500. So it's 43 minus, not plus, 0.005 times 3,500. So F of 3,500 is equal to 43 minus 17.5. So F of 3,500 is 25.5 degrees Fahrenheit. All right, so problem number 4 is finding the range. We're given that the domain of g of x is equal to 4x minus 12 is 1, 3, 4, and 7, and I want to know what is the range. So if you'll remember, the range was our output or our y value when we plugged in those numbers for our x value. So we use these little brackets to say these are our range. And I'm going to plug in 1 for x, so 4 times 1 minus 12. 4 times 1 is 4, minus 12 is negative 8. So my first point is negative 8. My next point is 4 times 3 minus 12. Well, 4 times 3 is 12, minus 12 is 0. So my next point is 0. 4 times 4 minus 12. Well, 4 times 4 is 16, minus 12 is 4. And my last point is 4 times 7 minus 12. 4 times 7 is 28. 28 minus 12 is 16. And there we go. Those are our 4 items in our range. That's your answer. Okay? So for letter B, we want to know what is the domain of y equals 3x minus 2 when 1, 2, 3, and 4 are our inputs. We want to know what the range is. So just because it's not written in function notation doesn't mean we still can't use this to find the range. So 3 times 1 is 3, minus 2 is 1. 3 times 2 is 6, 6 minus 2 is 4. 3 times 3 is 9, minus 2 is 7. 3 times 4 is 12, minus 2 is 10. Okay? All right, I want you guys to try letters A and B. So our equation, y equals 4 minus 5x, and we're putting in the domain of negative 2, negative 1, 1, and 3. So we start off negative 2, or 4 minus, 4 minus 5 times negative 2. 5 times negative 2 is negative 10. 4 minus negative 10 is 14. 4 minus 5 times negative 1. 5 times negative 1 is negative 5. 4 minus negative 5 is a positive 9. 4 minus 5 times 1. 4 minus 5 is negative 1. And 4 minus 5 times 3 is 15. 4 minus 15 is negative 11. Okay? And letter B, the domain of g of x is equal to 6x plus 3 is negative 2, 0, 1, and 3. And I want to know what is the range. So 6 times negative 2 is negative 12, plus 3 is negative 9. 6 times 0 is 0, plus 3 is 3. 6 times 1 is 6, plus 3 is 9. And 6 times 3 is 18, plus 3 is 21. Okay. All right. Moving on. We have problem number 5, identifying a reasonable domain and range. So I'm being told that I have 7 quarts of paint to paint the sets for the musical. A quart of paint covers 100 square feet. A of Q is equal to 100Q, represents the area A of Q in square feet that Q quarts of paint cover. What domain and range are reasonable for this function? And we want to graph the function. So first of all, our independent variable is our quarts. So that goes on our x-axis. Our dependent variable, what depends on the number of quarts we use? It's the area. All right, now we need to come up with some points to work with. So I'm going to make a table, and I'm going to just start. If I only use 1 quart of paint, how much can I cover? 100 square feet. If I use 2 quarts of paint, I'm going to use 200 square feet. Now, how many quarts should I go up to? Well, it says I have 7 quarts to work with. So I'm going to go 3, 4, 5, 6, 7. So 3 quarts gets us 300, 4 quarts will get us 400, 5 quarts will get us 500, 6 quarts will get us 600, and 7 quarts will get us 700. All right, so let's take a look at our graph. We only need to graph quadrant 1, so we only used quadrant 1. I only need to go up to 7 quarts because that's all I have to work with. So I'm going to just go 1, 2, 3, 4, 5, 6, 7. I only need to go up to 700 square feet because that's the most that I would be able to paint. So we have 100, 200, 300, 400, 500, 600, 700. And now I just need to graph my points. So I have a point at 1 quart and 100 square feet, 2 quarts and 200, 3 quarts and 300, 4 quarts 400, 5 quarts 600, 7 quarts 600, 700. Now, is this going to be a discrete graph or a continuous graph? Well, I can use all of the paint in the quart, but I could also use just like half the bucket. I could use a quarter of the bucket. I could just pour out a little bit. I could just dip my brush in. So it's going to be a continuous graph. So we need to just draw our line and connect the dots. All right, so I want you guys to try letter A on your own. So Lorena has 4 rolls of ribbon to make party favors. Each roll can be used to make 30 favors. The function f of r is equal to 30r represents the number of favors that can be made with r rolls. What is our reasonable domain and ranges for this function? Graph the function. All right, so 4 rolls, 1, 2, 3, 4. Let's make sure we label our axis. We've got rolls of ribbon. So we're going to put favors on our y-axis. And now I need to figure out what points I'm going to need. So r and f of r. So we have 1, 2, 3, and 4 rolls, because that's the maximum that we can have. So 30 times 1 is 30. 30 times 2 is 60. 30 times 3 is 90. And 30 times 4 is 120. So now I can take a look and I can see that on my graph, I only need to go up to 120 square or favors. So I need to label my scale, so I'm going to go by tens. And I'm going to write just every other number so my graph is not as cramped. But you'll see each line goes up by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. All right, so we've got our scales, we've got our labels. Now we just need to graph our points. So we have a point at 1 and 30, 2 and 60, 3 and 90, and 4 and 120. And it's going to be a continuous graph because we can use any portion of that roll of ribbon that we want. All right, that's the end of lesson 4.6. So I want you guys to make sure you write down your level of understanding. 1, I'm lost. 4, I can teach this lesson. Be truthful to yourself. If you are writing down a 4, I'm going to look at that and think that you really know what you're doing. And if you're writing down 4s and you're getting D's and F's on your quizzes, or maybe you're not doing so well on your lesson quizzes, then maybe you don't understand it quite as well as you think you do, and you need a little more practice. Okay, so make sure you're being honest with your level of understanding. Write down any questions you may have come up with during this lesson, and do make sure that you write your summary of what you learned today. That's all. Have a good night, and I will see you all tomorrow.